All right, 9b, we're going to look at adding and subtracting rational expressions. So we did multiplying and dividing. Okay, so now we're going to look at adding and subtracting. And just like in elementary school when you did adding and subtracting fractions, you have to have a common denominator. All right, so this is a problem that you have probably seen before. And so we have 3 and 4. In elementary school, they probably made you list out the multiples. So like 3, 6, 9, 12, 15. And then they made you do multiples of 4. So 4, 8, 12. And then here was the first common multiple. So that's going to be our common denominator. I don't really care if you list them out like that. The shortcut is just to multiply them by each other. So I would multiply this fraction by 3 over 3 because there's a 3 in the denominator of this one, and this one by 4 over 4. Okay, so my common denominator here is going to be 12. So on the first fraction, 4 times 2 is 8, and 4 times 3 is 12. So I have 8 over 12 plus 3 times 3 is 9, 4 times 3 is 12. And then when you add fractions, you add the numerators. So 8 plus 9 is 17. You keep the denominator the same. If you can simplify this, you need to, but 17 over 12 is already simplified. Okay. All right, so now we're going to throw some x's in there. All right, so I have 3x and 4. So this time I'm going to make my common denominator 12x. All right, so this side gets multiplied by 4. And this side gets multiplied by 3x, so that I end up with 12x on the bottom of both fractions. All right, 4 times 2 is 8. 4 times 3x is 12x. Plus, over here, 9 times 3x, or 3 times 3x is 9x. All right, 4 times 3x is 12x. And so now when I add, 8 plus 9x cannot be combined because they are not like terms, since they both don't have an x. All right, and then I have a 12x on the bottom. Remember, you cannot cancel out these x's because this term does not have an x. So this would be my final answer because there's no common denominator between, or common multiple factor between 8, 9, and 12. Okay, so here we have example 3. So if you can factor the denominators, you should. All right, so like this one, 3x, I can't factor, but this denominator can be factored. So I'm going to leave 2 over 3x. Okay, and then over here, this I can factor out a 3x. All right, and then I would be left with x plus 2. So my common denominator, they both have 3x, and so this one needs an x plus 2. So my common denominator is going to be 3x times x plus 2. So this one is good. This one just needs to be multiplied by x plus 2 on the top and the bottom. All right, so on the top, I'm going to like distribute this out. So 2 times x would be 2x. 2 times 2 would be 4. Okay, on the bottom, I'm going to leave it factored, 3x times x plus 2, because I just need a common denominator down there. And then the second fraction we didn't change at all, so this is 3x times x plus 2. Okay, so on the top I add, so this would be 2x plus 8, and then on the bottom I'm going to leave it as 3x times x plus 2. If you can factor anything to simplify, you should. So on the top, I can factor out a 2. So it would be 2 times x plus 4 over 3x times x plus 2. Okay, and in this case, that's simplified. But if we could simplify something here, we would need to. So that's why we would factor the top to see if there's anything else that could be simplified. Okay, so I'm going to skip ahead to example 5 because example 4 is very similar to 3, so you can try that one on your own. Okay, here there's nothing that can be factored, and so my common denominator is just going to be to multiply them by each other. Okay, so this fraction is going to get multiplied by x minus 3 on the top and bottom, and this one is going to get multiplied by x plus 4. On the top and bottom. So on the left side, I now have 2x minus 6 over x minus 3 times x plus 4. And on the right side, I now have 6x plus 24 and then still x minus 3, x plus 4 on the bottom. So now that I have my common denominator, I can add the numerators. All right, 2x plus 6x is 8x, and then negative 6 plus 24 is 18, and that's going to be over x minus 3, x plus 4, okay? And then don't forget to factor the top, because there might be a case where we have a common factor that we could cancel to simplify. So 8 and 18 are both divisible by 2, so I can factor out a 2, and that leaves me with 4x plus 9 over x minus 3, x plus 4. So in this case, there's nothing that could be simplified, but again, we always need to factor that top just to make sure that there's no more further simplifying. Okay, and then one more example. So everything we've done so far is addition. Now I'm going to do subtraction. Okay, my common denominator is, because nothing can be factored down here, I'm just going to multiply them by each other. So n minus 4 times n plus 1. So this fraction gets multiplied by n plus 1, and this fraction gets multiplied by n minus 4. Okay, so over here, 5n plus 5 over n plus 1, n minus 4. Minus, here that would be 4n squared minus 16n over n plus 1 times n minus 4. Okay, now when you go to combine your like terms on the top, make sure that you are subtracting. So what I would do if I were you, I'm going to write this as one big fraction, so it's 5n plus 5, and then it's minus, put this in parentheses, 4n squared, okay, minus 16n. And then the bottom stays the same. So what happens there is it's 5n plus 5, and then minus 4n squared, but then minus negative would be plus 16n. Okay, so when it's subtraction, you got to make sure that you're subtracting both numbers, and the easiest way to not mess that up is to just distribute it. Okay, so now on the top I would have negative 4n squared. 5n plus 16n is 21n. And then I have this plus 5. All right, and that is all over n plus 1 times n minus 4. Okay, it won't usually happen, but we need to double check that the top of this cannot be factored. So I would be looking for numbers that add to or multiply to negative 20 and add to positive 21. And that's not possible, so this would be my final answer. All right, and that is it for adding and subtracting rational expressions.